Hey, good afternoon, everyone. So I'm Lyle Burtz. I'm from Sprint, and we're going to go through the next half hour and updates on the MCORD projects, C3PO and NGIC. And we'll talk a little bit about the changes that have happened in the project since about April. So the current state of it is that we actually have the repos actually closed for access. So we found that in July of this year, we had actually sourced a project that actually had some GPL code. That was an older project outside of inside the MCORD stuff within the C3PO side of the project, particularly around the MME. We also found that as we were doing license compliance checks, because we want to make sure this code is viable for production, we also found that in a lot of these tools, they appear as duplicates. And what's really important about that is there's no license issue, but the fact that you see similar code appearing in other projects with different licenses can be confusing to folks. And so what's happened is Intel and GS Labs have taken the time to go back through each one of these potential violations, figure out if it's a real violation, and then adjust the code accordingly. So that's taking quite a bit of time. We're currently past the license conflict aspects of the project. And what we're doing is, because we have essentially a clean code base coming in, we decided to take a little extra time. So now what we're actually doing is running it through professional security scan tools to see if there's any sort of recommendations they would make in terms of open source and security, risk or violations. And so we expect the code to be available in the first quarter, publicly again. And what's important about that is you're going to get a very clean code base. So you'll have all of the licenses conflict-free. They will be basically with Apache 2 compliance, and we'll have the added benefit of the security scrutiny on the code base. So with that, what we also decided to do was to intentionally make for new repos. So this is the current state of the new repositories. So before, we actually had really only 3 repositories: NGIC, which was the control plane and data plane. So basically the S, the P, or the SAE gateway, depending on how you started it up. We also had C3PO itself, which was really all of the other aspects of the code. And we had then a version of free diameter, which is an underlying stack. So free diameter is a very popular open source stack that's been out for several years, and we use it as well in terms of the project. So we had a branch of it where we had our own libraries, and we had a few enhancements. Because if you actually go out to that site, they keep the code out and available, but because diameter is being retired, they no longer actively enhance. So we decided to keep that. So that was the 3 projects. Now what we're doing is, you can see a bit of a reorganization here. So we actually have within C3PO the HSS, the PCRF, and the CTF, and we're still using Cassandra as our backend data store. The MME is no longer a part of the C3PO project. There were a lot of conflicts there. So we had a parallel project going on with Intel and GS Labs with an entirely different code base. And what we were focused on there was performance. And so we just basically accelerated that project, and that's now called OpenMME. That'll be another repo you'll see out. And then the other project, and we'll have Somnath come up here in a little bit from Intel, talk about it, is SGX CDR. And the intent of this project really is to accelerate basically compliance with Sarbanes-Oxley or other requirements for accounting, so that we can really, once we get the code functionally ready, pass the last couple of hurdles that's typically required of a regulator or accounting for various geographies. So other projects, OSS utils and stuff, are out there. Really, this is a representation of the code being reused more and more into the overall project. Now, we commonly get asked, what should I do if I'm downloading this code, and how well does it scale? So we also have what's called a frame recommendation. So we have an initial frame recommendation of when you download it. I think Intel, I think, recommends 100 cores. Really, we would advise you using maybe 30 to 42 CPU cores, a 10 gig NIC, because you can definitely generate 10 gig, And if you're using load testing, 40,000 users, about 1,000 signaling transactions per second is probably a start. Now, if you're willing to go a little further, beyond the out-of-the-box experience, you can actually get these numbers much higher. But at that point, right, you've got to move past, you've got to start reading manuals. So there's a little bit more work, but you can definitely actually scale these things much higher than this. But we felt that 40,000 for this number of cores was a reasonable amount for this. It also kind of sets the precedent, right? We're not a toy project. We're not talking about hundreds of users here. So it kind of gets you kind of that initial starter kit. So we do have a couple other things in here. So at one point, the older MMEs supported a lot of the IoT features. So we still have the S6T on the HSS. Actually, we also have S6M, S6N available as well throughout the infrastructure. You'll notice we don't have the GX interface yet on the, actually on the control plane side. So it's obviously on the PCRF. So functional improvements, I'm not going to read through this, but there's quite a few actually set up here. So we'll talk a little bit about the new version of the data plane called NGIC Run to Completion, the SGX CDR. We are pushing in OAM compliance, and we have quite a bit of future stuff, and time permitting today, we'll go through those. Currently today, if most of you have seen the older repos, we actually do a stress test on a regular basis as part of CI/CD. So we're always making sure we're at least getting 10 gigabits per second out of a single CPU core every time we do a commit. That's also important to us to make sure that we're not backsliding in terms of any sort of performance. So that's still there, but we've actually expanded our basic test, as you can see here, beyond just the initial attach of a default barren load. So that's pretty much going to be added into the standard rotation with the code base, and we'll keep expanding that basic test as part of our CI/CD regression as we get more features. So the first enhancement is NGIC RTC. So the traditional model that we had for NGIC was a system that actually ran 4 cores, could run up to 8. We gave guidance back then of up to 1.5 million users if you were interested in pushing that over the 8 cores. We were asked by various stakeholders, operations stakeholders and other operators to look at a much skinnier model where we could actually minimize the cores and get it ready for the edge. And so what we settled on was 2 things. So we settled on only a 2 CPU core design. So once again, we're doing about 2 million packets per second, so really around 2.2. If you're requiring ARP or other things, you know, you're actually running now through the Linux kernel to actually update your routing tables, which is really great. So now operators can add their signaling protocols, their IGRPs and their EGRPs on the Linux side using standard Linux signaling software, and still then allow it to actually update the routing tables on the gateway side of NGIC. So the nice part is you don't have to wait on us on the project to actually basically implement your favorite signaling protocol. And you don't necessarily have to wait on us to actually implement an interface that you're interested in. So on the Linux side, you run what you want, and then we actually then run basically the uplink and downlink packets on a couple other cores. The packets that we send up through the core are, like I said, packets we don't know how to route or handle. And we'll also talk a little bit later. They're also packets we're making copies of. So the copies of packets that we run through there, there's a couple of purposes. Most people, when they think of packet copy, they think of lawful intercept. And that's definitely a valid use case. But realistically speaking, we wanted to add it in so that we could actually troubleshoot individual users from streams, so that when we're actually on a support call, right now, today, in a lot of our stuff, we actually have to log into the network elements and actually have to do PCAPs. And it's incredibly painful. So one of the things we did was we heard our customers, and we said, look, we're going to go back and we're actually going to kind of reuse that intercept architecture to basically allow our operators, when they're troubleshooting with the customer, to get a live copy of the packet stream so that they can actually do these live captures. So that, in essence, allows us to really kind of reuse the same set of code that most people think of as kind of that intercept code, and give us kind of a new capability in terms of troubleshooting for customers that really need help out in the network. The RTC actually runs all of your standard modes, SAE gateway, S gateway, P gateway, and what we call multi-role mode. So we actually, by configuration, allow the control plane to kind of pick a mode or to kind of be dynamic in the mode. And once again, that was customer feedback that we were pushing. So I think, Somnath, if you don't mind coming up here for a few slides here and telling us a little bit about the SGX project.
Excellent. All right, so if you look at, do we have the slide, the next one? I want to use a, yeah, here? Okay. Okay, so did you show this slide already? No, no, right? So I think Lyle will cover the rest of this in subsequent slides, but the reason I'm going to show the slide first is I want you guys to focus on the green boxes here. So what happens today is the packet gateway, when it's handling the data, it's also generating the charge records. Those charge records are, without this SGX solution, the charge records are put on a storage, maybe on a remote storage in clear. And it's very easy for someone to go and look into those records or even tamper those records. So the challenge here is when it comes to the security of those billing records, when the auditors come in today and challenge the operators to prove the integrity of those records, it becomes very difficult for them to prove. Sometimes it takes months to years to prove that no, the records have not been tampered with. Now, it was okay for the operators to say, hey, the records are being handled with a black box, and the black box could be any vendor-specific black box, and finally they would agree, okay, it's a black box, the records are being handled inside. It gives you a notion of security, but it's actually not secure. But when we move to open platform solutions, it's running on a standard off-the-shelf hardware. It's a software solution. Sorry? Oh, for the audio, sorry. So with the standard off-the-shelf hardware, sorry about that. What happens is you're running it on a standard off-the-shelf hardware with open source software. Now it becomes even more difficult to prove that the charge records have not been tampered with. And that's where SGX comes into picture. SGX gives you a beautiful solution to this problem. The way it solves the problem is by using a CPU feature which is available right now on Intel Xeon E3 platforms, Intel Software Guard Extensions, SGX. The way it does it is it creates an environment on the CPU for your code and data in such a way that even the operating system or the kernel, the VMM, or even any root privilege software cannot access inside that environment to access your data or code. And not only that, you can challenge that piece of software to prove itself, and it can prove itself that I have not been tampered with. So now it becomes very easy for the telcos say, hey, the billing system today is being handled by Intel SGX, and this is the way it is done. Now the best part about using SGX to protect those records for confidentiality and integrity is the encryption keys that's used to protect the records, they are generated inside the enclave SGX environment. So it's generated inside the environment in a way where it doesn't, the keys never come outside that enclave or the SGX environment. And it's very easy to prove that. It's called SGX attestation. Now it becomes very easy for the operators to say, hey, we don't even have the keys. Even if we want to go and tamper with those records, we can't even do it because we don't even have the keys. And all these steps could be cryptographically proven, and there's some set of 6 or 7, I forget the number, 6 or 7 algorithmic steps that the auditors need to follow, and boom. Once things match up, it's guaranteed that the records have not been tampered with. So on the current generation platforms, based on what the SGX billing records require, it's actually 92 MB. 92 MB is sufficient. So the memory he's talking about is, sorry, what's your name?
It's okay, doesn't matter.
Okay, doesn't matter. Okay, so someone from audience, he pointed out the question on the amount of secure memory available. On the current SGX E3 platforms, it's 92 MB megabytes of secure memory, but that's the physical memory. We have to keep in mind that's physical memory. The virtual memory for the process to use that space is unlimited. All right, so any questions on SGX? Otherwise, I'll hand over to Lyle.
So as you can see, right, so we really rely on SGX to kind of bring in kind of that last aspect. We find that typically, right, we have a bunch of great open source that's functionally ready to go, but where we tend to get tripped up, right, is especially the second we say we're going to do it as a revenue generating entity. And so Intel's been incredibly helpful in helping us solve that issue so that we can really go from the moment we're finished with code to not just a field trial or something, but production readiness and allow revenue generation. So we've talked pretty much about the components and everything else today. So I'm going to kind of move into just quickly the 1Q19 state that we're actually looking at. So we're looking at a couple of new features. So we're going to finish off the GX. We already have it on the PCRF. We do not have it on the control plane. And we talked a little bit about user level packet copying. It's for troubleshooting. It's for lawful intercept. We have to remember, though, that these specs are not complete in 3GPP. So when we say this is as far as we can go with the code, but by no means are we claiming any spec compliance. The specs are not finished. Also, the same story with SX. So we're actually going to upgrade the control plane to data plane, which is using currently a protocol we've been using for several years at the beginning of the project that was developed by Intel to actually do this communication. So the irony is this project's been around for about 4 or 5 years. So this actual protocol predates SX, and it predates even some of the IETF work in FPC. So we're going to go ahead and upgrade that protocol to SX, but once again, just reminder, SX still has several items that are still out for future study. So although we may be spec compliant, right, there's still open gaps that bring you to production. So we're filling in those gaps so that we can get toward a production quality sooner than later. And then once the specs have been updated, and we hope they'll be updated in early of release 16 and not toward the end of release 16, once those specs are updated, you'll see us go ahead and schedule out basically updates accordingly. We are also implementing UPF selection via DNS. That was a recent addition. If you follow the SX spec, I believe it's Annex B2 or B4 in 29244. And then option 3X. So what's important about that is those are a lot of new AVPs. There's not a lot of new messages. So we felt that the time was right, and you're hearing about 5G everywhere, to go ahead and push that into the code base. So we're still recommending the single frame with this on the out-of-the-box experience, but also look for us to actually do an upward revision of those numbers once it's available. So that being said, I'm going to kind of jump just quickly through some common questions because I know they're out there and we get asked those a lot. So I'll just run it up. So for the next gen core, we are option 3X focused, right? We have to remember NGC as specs is not complete. All you're going to get today is EMBB. So we want code now, and we want to actually start pushing this stuff toward product realization sooner than later. So hence the focus on that. We are with SX and N4, we are migrating the data plane portion of the project to a UPF as quickly as the specs permit us to go through, run through. So scale, as I said, you can go much higher. And in fact, right, just looking at Cassandra key spaces, and we've talked with several people about a trial, it's not unusual in the key space to support 1 billion entries. It's really 2 billion entries, 1 billion for policy and 1 billion for HSS records. And then we have a hierarchical key space design that's actually on the design books that now gets us that 10 to the 18th. Part of the reason for that is we always hear this number in IoT about getting to 1 trillion devices by a certain date. So one of the things we wanted to do was look at, design-wise, could we even design a system like an EPC or eventually an NGC that can do that? So we're happy to say design-wise, on paper, there's nothing that will stop us. I would like to, with a lot of my partners, do a test in 2019 to see where things break beyond a billion entries. But we've got a lot of other work to do in this. Field trials and productions is a pretty common question. So if you ever hear me talk, I always talk about operators running out of excuses. And what I mean by that is we're always going to say no if there's an easy answer to deny something. So I think we're going to run out of excuses in 2019. And we'll be talking a little bit more. I have a keynote on Thursday. We'll be talking a little bit more about running out of excuses and give you a little bit more timing on that. So I think the obvious one is a fixed wireless 4G that will run out of excuses on first. I think we can make an excuse about the control plane between 4 and 5 and what's too early and too late. But I think we are going to run out of excuses in 2019. So the other fun part is, right, we're kicking out FPC. And that's really because the SGX protocol is there. Most people expect it, and in an edge design, it's the best way to keep things minimal. So it didn't go away, it didn't disappear, but you will see the SDN controller back in future revisions of the project. It's just now, because we have a bit more of a production type of focus, we wanted to make sure that really we had the SX in and played. Once again, 1Q19 is our target, our guidance that we have exiting the process. We, like everyone else, would like to have the code available earlier. And we've talked about the repo access. It's been available. So what I'm going to do here, guys, is we've got about 7 minutes. So I'm going to open up the floor to questions. If there aren't a lot of questions, I can also go into detail about the actual features and the future work if people are interested. So let's stop right now. Yeah.
Sure. If you go back 2 slides to common questions, 1 of 2, there's a bullet point there. You talk about the one more back.
Yeah.
Yeah, the MME feature set will be the largest limitations. Could you just expand a bit?
Yeah, so the older MME item, the older MME project was developed by Radisys. It had quite a few features. When we started on the MME, Open MME project, we were focused on performance. And so we really focused on a smaller feature set. And so that's what I really mean there is if you're looking at the older code, there's a delta between the old code and the new code because they're 2 completely different code bases. And so what I would say is don't get super excited when you download this code that it's going to be like the old. And like all MMEs, right, the MME has the hardest job in the LTE core. So there's lots of NAS messages. My favorite ones are the unhandled, or what they refer to abnormal condition section, which is just pages and pages of very obscure corner cases. So don't expect the MME that's out there to be this full-fledged, really great, it's ready to go sort of MME. This is open source, and the MME is a lot of work. So that's what we mean by that. All right, any other questions? Okay, I'm gonna then just kind of quickly blast through in the last few minutes here some of the future work. So the SX support, what we've got here is kind of what we talked about. So you've got your S11, your S5, your S8, your SX down below. We are doing something a little different, right? Because remember I said the spec isn't done. So the spec has several things out. So what you see off to the side is what we're doing for charging to make sure that we're ready for Sarbanes-Oxley compliance and other auditing compliance, and the user packet copy infrastructure. So this is once again reflective of the lack of specification or lack of completeness in the specification. The multi-role support is an interesting one. It is controlled by configuration. This was a request from multiple operators for operations. So we can restrict both the control plane and the data plane to come up in very specific roles as SP, SAE, or there's really what we refer to as ad hoc mode, which is basically however the signaling's using you, go for it. So That's actually coming in the first quarter, and once again, reflective of operational request. The user level packet copy, I'll leave this to you. There's quite a bit to be unpacked here. We talked about the fact that the packets go from kind of the bottom set of cores, that's really the DPDK doing the work, through the DPDK kernel NIC interface, KNI. Now, the easiest answer here is we just take a copy of the packet, we pop it into a tunnel, and it goes on to its destination. But it's really important to understand that there's a lot more to unpack with this, with user-level packet copying, regardless of how you're doing it. So, you're going to have, during handover and stuff, when you're doing these copies, you can have, in some cases, up to 8 GTP tunnels active in a user packet copy session. So there's a lot of extra work. It's not enough to say, we're just going to take a copy and run it across. We've got a lot of housekeeping to do with this feature. Especially when you look at primary and secondary cells with like option 3x and handover. If you look at dormancy timers. So there's a lot of things going on in the various modes that you see over on your right. Now, the other side is this is your classic lawful intercept architecture. We're totally stealing it. Just because what's actually happening here is it's the same use case. We want to be able to take the user's packet, bring it over to an operator to actually do that troubleshooting. So you see the traditional X interfaces. What's important, if you haven't followed the specs recently, they've already made accommodations at the architecture level with the X3 control and the X3U interface for SX. But they haven't filled in all of the specs for the low-level details of those interfaces. So architecturally, we have the design in place at the stage 1 level in 3GPP, but we don't have the details. But this is essentially how this is going to work if you're looking at the specs. So we're going to go ahead and, like I said, code it as close to compliance as we can, and then as the specs kind of come back in and fill in, or in some cases, we're actually already, through this code development, we're actually updating and informing the specs with errors and corrections. So it's kind of this cycle, this virtuous cycle now, where we're actually helping them out and getting some benefit from that. And this is just the overall analysis of the set of features. Once again, we packed this in not because we like you guys to read lots of slides, but we know this will be made available online so you guys can look at this at a later date. Anyway, guys, that's it in terms of kind of the overall features, and I have time for at most probably 1 or 2 questions. So, yeah. Let me kind of back up to an architecture slide here.
A question on the OpenMME. Is
Yeah.
it the open source project? Because I can't find it anywhere.
Yeah, you won't find it today, right? So this is part of the closed repositories. So one of the things we talked about earlier is all the repositories are closed because our friends at GS Labs and Intel are taking it through license compliance checks, as well as, and I don't know why no offense, my partners, I don't know why you decided to take on the security scans as well, but I guess they decided they like doing extra work, or we're looking for extra credit, I'm not really sure. But they went ahead and went, well, since we've gone this far, let's do the security scans. So this is one of those where I really want the code now. But you know what, if they're gonna do this extra, I'm willing to wait. Although I'm not willing to wait that long, guys, so hurry up. Anyway, thank you.
The question I had was, what is the motivation for putting it in open source?
This is a great question. I got asked this yesterday at another conference. So I'm in technology innovation and architecture. So a lot of people think of us as Sprint as R&D. Really, right, a lot of our work is helping out with standards definition or basically rapid prototyping, proof of concept. I like to think of us as risk mitigation, right? When the risk is really, really high, our job is to get it down to the point that we can take a feature or something, working with partners, hand it off to our downstream organizations, and they have a high probability of getting into the network in 18 months or less. So my group works on all sorts of things. We found ourselves probably about 5 years ago constantly getting peppered with questions about, we're thinking about this feature, it just got finished in the spec, and then I get 2 horrible questions, right? So they would just finish the Word document and they'd hand it to me and they'd go, what do you think, will it work? And then the marketing guys would come in and go, oh, by the way, can we make money off of it? Now keep in mind, it was just right out of 3GPP, right? It's a draft. And so we can't go to our partners and say, could you go ahead and code this and actually build it and get it all done on your own dime? And then we might be able to say, you know what, it's actually a pretty good idea, right? There's too much risk there. So what we started realizing was, how can we go from spec to code as quickly as possible, kind of get a good idea of, will it work, right? So we inform the standards, this seems good. At the same time, we also need to go down to our downstream organization and say, you know what, it works on paper, but maybe it's chewing up too much memory or it's too intensive. But what we wanted to do was really go to our partners and say, look, right, we're not really worried about this going in production as much as we want it to be production viable, so that when I go to a partner and say, look, I know this is a new feature, it's hot off the press, but based upon our work out on the open source side, right, where everyone's collaborating, we think this will work, we think there's a business case, and we've done some risk mitigation, not all, but some risk mitigation. So how do you get from that spec, that fresh off the press ink, to something that at least is halfway viable as a product or a feature as quickly as possible? So that was our biggest motivator. And because I think it's unfair to ask these questions of our partners. It's unfair to ask these questions of the standards guys, right, in terms of feasibility and stuff. So that was our biggest motivator, and that's why we started it. Now, initially, we started with just functional, but then the next question we got was, does it scale? And so we were like, okay, so we were hoping we could get away with just adding functions, but we had to add that scale piece. And then the next question we got was, I'm glad it scales, I'm glad it's functional, is it production ready? So it's like, come on guys, you're dragging me toward actually building an EPC. And lo and behold, here we are. So, all right, thank you so much guys, appreciate the time.